Lesson 4, Advanced Integration Techniques, Partial Fractions, Part 1, Example 1, find the integral of x over x squared plus 4x minus 5 dx. Now what we need to do here is to factorise that bottom line. So the integral becomes x over, and this becomes x plus 5 times x minus 1 dx. Now then I'll just go away and write this as x plus 5 x minus 1 equals some constant a over x plus 5 plus some constant b over x minus 1. Now looking at only the numerators, x must be identically equal to a outside of x minus 1 plus b outside of x plus 5. Now removing those brackets, we get ax minus a plus bx plus 5b, and then regrouping, we'll have a plus b outside of x plus 5b minus a. Now equating coefficients, we get a plus b is equal to 1, and I'll call that equation 1. And I get that minus a plus 5b equals 0, because there's no constant term. It's 2. Now if I add 1 and 2 together, I get 6b is equal to 1, b equals 1/6, and putting that back into here, it's obvious that a must be equal to 5/6. Right, now I can go back and I can write that as the I as the integral of, and because it's got a common denominator of 1/6, I'll take the 6 out the front, and I'll have now the a was that 5 over the x plus 5 up here, okay, and plus 1 over x minus 1 dx. Now you can see that's true. If you do a little quick multiplication, you get 5x minus 5, and you get x plus 5. The 5's go out, and you get 6x, and 1/6 of 6x is x. It's a little quick check, just in case you made some little error back up there. Alright, so now it's a fairly easy thing to integrate. That's 1/6 outside of 5 log of x plus 5 plus the log of x minus 1. If you want to put that all together, you'll have 1/6 the log of x plus 5 raised to 5, and this will be plus these times, that's x minus 1 as your final answer, or plus c. Okay, example 2, evaluate the integral between 2 and 1 of 1 over x outside of x plus 1 all squared dx. Now we'll look at this is a partial fraction type, so we'll look at the part in here. We'll write that as 1 over x into x plus 1 all squared equals, now this will be an a over x plus, we'll have a bx plus c. It's a polynomial in degree 1, so it's 1 less than this one, over x plus 1 all squared. Now 1 will be identically equal to a outside of x plus 1 all squared plus x outside of bx plus c. So that becomes a x squared plus 2x plus 1 plus bx squared plus cx, and that's equal to ax squared plus 2ax plus a plus bx squared plus cx. So 1 equals a plus b x squared plus 2a plus cx plus a. Therefore, a plus b equals 0, 2a plus c equals 0, and a is equal to 1. This implies that b equals -1. That's a 0 there. And of course, c must be equal to -2. Right, so this would have been equal to 1 over x plus minus x minus 2 all over x plus 1 all squared, or you could have it 1 on x minus x plus 2 over x plus 1 all squared, and that's what our integral would be. So our integral I equals between 2 and 1 of 1 on x minus x plus 2 over x plus 1 all squared dx. And we're still out of the woods because we've got this rather complicated thing here. So what I'll do here is I'll write that as minus x plus 1 plus 1, and we'll put the x plus 1 underneath it, all squared. I'll do that. Remember, all this is negative is applied to the lot. X. Right, so that now becomes 1 on x minus 1 on x plus 1 minus, now this is x plus 1 to -2 dx. Now we can integrate. So that becomes the log of x minus the log of x plus 1. Now we add 1 to the power, minus 1 over minus 1 makes it plus 1 over x plus 1 between 2 and 1. Okay, now we can actually fix this up a little bit here and write that as the log of x over x plus 1 plus 1 over x plus 1 between 2 and 1, and that's equal to the log of 2/3 plus 1/3 minus the log of a half plus a half, and that all comes down to the log of 4/3 minus 1/6.